So here's just a couple of examples. Let's blow this up, of using logarithm rules. I want to make this real quick if I can. I know I have a problem with that. But so for example, okay, suppose we have the expression ln of x squared root yz. Can we rewrite that in a different way? And a good question is, why would we want to do that? We'll see when we solve equations involving logs. That's going to be one of our motivations for using these guys. Let's see what we can do. Well, this is a product. The x squared is times the root yz. So let's just use one rule at a time. When you get good at this, you can do it sort of all at once sometimes, but it's a good idea to be careful with it. Okay, well, let's see. Now we've got a power inside a log. That's something that can be taken down the rungs of the ladder. And so that's going to be 2 ln x. Remember, the power goes out in front without a log. Now this guy, let me just rewrite it. That's yz to the 1/2 power. And so you can think of that as the same kind of rule. So it's 2 ln x plus, and then the 1/2 comes out in front. And one way I like to think about it is the square root, which is the opposite of squaring, goes to 1/2. Division is the opposite of multiplication. And that's yz. And then, oh, okay, that's a product as well. And so that's going to be plus 1/2 times the quantity ln y plus ln z. And your big obstacle here, your big pitfall, is putting down the rules wrong. Like thinking ln yz is ln y times ln z or something like that. Okay, so there's one example. Another example, which is kind of cooler in some ways, would be collecting things together instead of sort of separating them out. Okay, so suppose I had ln of a plus b plus ln of a minus b minus ln of a squared minus b squared. Now, big possibility for a mistake here is to try to invent a log rule that takes a plus inside a log to something. This is not ln of a plus ln of b. This is not ln of a minus ln of b. You cannot separate these guys out. But we're going to see that this actually does do some pretty cool stuff if we instead collect it together. Here, up here, we took one log and transformed it into 3 logs. That's kind of a weird thing to do if we think log is a complicated operation. But there's definitely advantages to this process sometimes, so we haven't seen them yet. Here, we're going to see that this is going to simplify dramatically. And the first thing that's going to happen is we're going to reduce the number of times we have to think about the logarithm operation. So let's combine the first two with a plus goes to times idea. And so that's going to be the quantity a plus b times the quantity a minus b. And I'm just going to leave the second one alone for now. And now I'm going to purposely do things in a little bit of a complicated way because I want to save the punchline for later. I'm going to take the log rule and says the difference turns into a quotient. Now, hopefully, if you're looking at this, you might say, I know a simpler way to see this. But I want to observe of how one would do this with log rules. So the difference of logs turns into the quotient, the log of a quotient, sorry. Well, hey, guess what that is? That's a squared minus b squared over a squared minus b squared. That's just 1. And the log of 1 is equal to 0. Now, the shortcut would have been, if I had expanded this out as a squared minus b squared here, we just had ln of a squared minus b squared minus itself. And that's another reason it could become 0. But it's kind of cool how combining it all into one log lets these guys interact with each other, lets them cancel down to 1, and then ln of 1 is equal to 0. Okay, that's enough for that.